Hi guys, this is Rashid and you're watching Step-by-Step-Robotics. So it has been a long time that I didn't upload the video, so I was quite busy with my POC project and my company's work. Today I would like to introduce the latest JMOAB, the JMOAB 06. What happened with the previous version of that is like we apply this and we use this on some of our application in the robot. We observed that there is some problem, some defect and some bugs. So we try to improve that from version by version. And then finally we came up with this 06 version, which is quite pretty much stable from my point of view. And it almost covers the application that you want to do for the robot development. And this is the video series about how to use the JMOAB with the ROS2. So we're going to start from very beginning and then until the application level. So let's get started. So here this is the JMOAB. So you could see there are many peripherals devices that you can connect to it. So down here there is one SBUS input port and 3 output PWM ports. So you can control 3 servos or you can use it in PWM cart mode. On the left here, there is an I2C port which you can connect the IMU or the I2C device. There is GPS port here which is connected to the Jetson TTY THS1 serial connection port. And also there is an SPI which you can connect with the SPI device. The black connection here is just for the ATCart ESC connector. At the back here, you will see 2 relays from Omlon and the 40 pins female connector and the PSOX microcontroller. So the right side white connector here is for the 2 relays. And here is the difference between the first JMOAB and the latest JMOAB. The board side is a little bit bigger and the port is also slightly different. And here is a Jetson Nano 4GB. So we just need to plug on the 40 pins connector. So make sure not to skip the pin because it's gonna damage the JMOAB board. And here how it looks like when it's attached together. So the IMU that support on the JMOAB is BNO055 and you can use either of these breakout board. And you just need to make the JST 4-pin connector like this. And here is the radio receiver from Futaba, which is going to provide the SBUS input to the board. So for the relay connectors, it's the same as the 2-cell LiPo balance charger port. So we need to make the cables for our control device and plug it on the board. Okay guys, so first thing first, we need to set up the Jetson Nano. And in order to use the ROS2 in the Jetson Nano, there are 2 ways we can do it. So first option, there is the NVIDIA ROS2 container that made by the NVIDIA. And the second option is to use the custom image for Ubuntu 20. So in that case, we can run everything in the local. So I prefer to use the second method. And I feel much confidence to run everything just from the local system. Okay, so if we go to the GitHub track lab here, and then check on the JMOAB ROS2. So here I mentioned that you can use the image from Q Engineering or use the X Ubuntu. So I prefer to use the first one, so you can check on the website here. Just scrolling down, then you just need to have like at least 32 GB of SD card and then download the image from the website here and then use the Balena etcher to flash the image to the SD card. So downloading will take around 1 or 1.5 hours, and then you flash by the Balena etcher. That will take around 5 to 15 minutes. So that is a kind of time-consuming process. So let's do that. So here you just need to download by clicking on here, but I already download one here. So here is an image. It will be around 8.5 gigabyte. So you also need to download Balena Etcher. So here you can just click on here to download Balena Etcher and just click on download and select the which OS for your computer and then click on download. Then you can execute that by this. So it will come like this, and then you just select flash which image do you want to flash, which is this one, and then you click open and then you click flash. But I already flashed this one, so I won't going to flash it again because it would take some time. So the image on the Jetson Nano that we have flashed, for this version, you don't need to do the initial setup for the Ubuntu. So the username and the password will be Jetson. So we just need to update the system and then install ROS2, and then we're going to move to the JMOAB. So next, we need to do sudo app update. Let's try one more time. Okay, cool. Then we just need to install ROS2. So open the Firefox. For Ubuntu 20.04, the Galactic is the latest one. But if you want to use Humble, you need to install Ubuntu 22, which we don't have it now. So just use the Galactic. Okay, yep. So once we finish install the ROS2, we're going to move to the JMOAB. So first, we just need to flash the JMOAB and then try to control the peripherals, like getting the data or control the LEDs, control the relays, and so on. So yeah, let's do that. So what we need is JMOAB itself and also the Jetson Nano. Because the JMOAB itself doesn't have power, so we need to plug the JMOAB to the Jetson Nano on the J40 pins like this. What you will need is this setup, and then so you will need this mini proc 3 to flash the firmware to the JMOAB and also the mini USB cable. And also you will need to have the Windows PC, which have the PSOC programmer installed. So here you can download the PSOC programmer by just search like PSOC programmer download, and then just click on this one. Then you scroll down. You can install the setup program, the exe file. Depends on the version you want to use. So for example, I use the one which is the 3.28.1, I think maybe this one. So you just set up this, and then you have this program running. So about the firmware that we're going to flash to the JMOAB, there are two types that you can use. One is the basic ATCart, the V1, this one, and also there is the PWM cart version, which you can use to drive the PWM driver type motor. But for the ATCart one, it's kind of specific, like a custom motor, so you will need to use this one. So we can just download this repo by just download zip, and then you can just show in folder, and you can just extract to just here. So here you have the firmware, this one. So once you power on the Jetson, then the JMOAB is ready to flash. Then you can also check on my GitHub repo here about how to install and download the software. So here we need to make sure that the V target is on this side. And then we're going to plug these to the JMOAB pin here, which is the pin for the programmer. So just put it like this. Then on the programmer, you just need to select the firmware that you want to use. So for example, I want to use this V1, which is the ATCart basic. So just select that, and then make sure that 3 of these data are green. Then that is ready to flash, and then you just click on program button. So make sure that you need to set up the configuration, same as mine. So using SWD 3.3 volt and all of these exactly same. So once it's done, it will show programming succeed. Then you can just remove the programmer and then restart the Jetson one more time. So once we flash the JMOAB firmware, then we're going to plug everything back, and we always use the battery, just only one battery to power everything. So the Jetson Nano needs 5 volts, so I have to use this DC-DC regulator to convert 24 volt from the LiPo battery to 5 volt. So this will be the regulated 5 volt. And for this test, we're going to test the relays by controlling the headlights. And this headlight needs 24 volts, so it's connecting to the relays cable here. It's connect with normal open. And also we have the BNO055 connecting on the I2C port. And we have the Futaba SBUS connecting on this port, so we can read the SBUS value from the RC transmitter here, which I use to control the robot. So then we already installed ROS. So next we need to build the package, the JMOAB ROS2 package. Okay, so we already installed ROS2 before. Then we just need to install some of the other dependency like SBUS2, TF transformation, transform2D, NumPy, and also the Qualcomm to build our package. So I already installed these. Then I'm going to make the workspace, which called the dev workspace. So I'm going to make dev workspace, and then inside there, going to make source folder. So we go to inside of these, and then we clone JMOAB ROS2 by this command. And then we cd out to the this directory, and then we use Qualcomm build and symlink install packages, select JMOAB ROS2. So in some case that we already have some other package and we just want to install just our package, then we use this argument to define. Okay, so just hit there. So it won't take so long time, just some few seconds, and then we just need to source our workspace environment by source install local setup bash. And one more thing is we need to export the ROS domain ID 1. We can use any of this number like 0, 1, 2, 3, 4 or something, but all of the device has to be the same ID in order to let it see each other. Or we can put it on the batch RC file like this one. So when we open the new terminal, it doesn't need to source this one by one. It just sources once we open the terminal. So just source-rc, because I already put it there. Then we're going to use the command ROS2 run JMOAB ROS2, and then ATCart basic. Then just hit enter. So it's going to show you that now the ATCart basic node is running and is publishing this topic and subscribing on this topic. So we can check on the SBUS RC channel, this one. So because we already have the RC receiver plugging on, then on the another terminal, we just run ROS2 topic. Let's run topic list first. Okay, then we're going to echo this one. So now my transmitter is on. It's like this. So my receiver is showing green LED light. That means it's binding together and it's on. So if I move my stick here, if I move this throttle stick, you will see that the channel 2 is changing. And once it comes back, it's just showing 1024 or around there. That is the middle value of SBUS. So if I put it down, then it will show less than 1024. Also for another stick, it will change as well. So you can use this button to do something else, like turn on LEDs or do some anything that you want to do with the switch. You can use this SBUS RC channel topic. Next, I want to control the relays. So first, let's check that what kind of topic. Wait a moment. JMOAB relays. So we can check the message type by using this topic info. So all this topic I use as a standard message. So just for easy for the user to use. So we already have 2 relays. So that means the first index is the relay 1 and the second index is relay 2. So now my headlights here is connecting on relay 2, so which is this port. Then if I type ROS, this terminal, okay, make it bigger, ROS2 topic pub JMOAB relays, and with the standard message and int 8 multi-array. So the data would be an array like this. So if I put 0 and 1, and wait for a moment, so you should see that the light is turning on. And if I put it back to 0, 0, then it will close. And next we want to get the data from the BNO055, the IMU data. So we need to run another node. So ROS2 run JMOAB ROS2 and then BNO055. So if we try to run this, so it's execute and then it just quit because it said that there is no calibration offset file. So here the file is inside the dev source and JMOAB ROS2 and script. So just for the first time that you want to run the IMU, you will need to have the calibration offset. So you just need to do it only first time, and then next it just use that file. So first we're going to run Python 3 and calibration, BNO 055 calibration like this. So it will show the status of the calibration. So system and stat and gyro and acceleration and magnetometer. So it should be all three. So now I need to move the magnetometer. So by do something like this. So for the acceleration, you may need to press the IMU in some of the angle like 45, 90, 180 degrees, and then just press it on the table and leave it. Then it should turn to 3. So here you will see that I already got the offset data, so that should be fine. But if it shows all 0, you may need to run that again, and then it will just immediately show some offset data for you. Okay, so if we run the JMOAB ROS2 BNO055 again, now there should be no error, and then it just run. So if we try ROS2 topic list, then we should see there is the JMOAB AHRS, which is the row pitch yaw of the IMU. So here is just showing row pitch yaw value of the IMU. And also, in some case, we may need to have like raw data of the IMU. So we can grab this topic to use. So ROS2 topic and echo IMU data. So you will see that here we can have linear acceleration and the angular velocity and also the orientation in the quaternion form. And that is how to set up the Jetson Nano and JMOAB and get some data of the IMU and the SBUS value and control the relays to control some device. So next we're going to move to the how to control the ATCart from the ROS topic, because we already have the ATCart firmware on the JMOAB. So please stay tuned.